Okay, this is another application of Lorenz force. So it's going to be Lorenz and current. So okay. Okay, so well, we have an expression for it. We have for Lorenz, it's going to be F equals QV cross B. Okay. Well, the thing is that if we think about a wire in a magnetic field, so I've got a current I going this way. So it's not really a vector technically. Okay. And I've got a magnetic field going again into the page. Okay. In terms of the mechanics of it, again, if we're using conventional current, so in this case, conventional current is the same as a bunch of little positive charges going this way, right? Positive charges. It's just a collection of them all going that way. So we think about that. If we use right-hand rule, we're going to get the same thing that we had before. We're going to get that we have with the other problems and with the right-hand rule. We've got a field that goes into the page, so our fingers go in, and our thumb goes to the right. So we're going to get a downward force on the wire. Okay, so in terms of the Lorenz force, in terms of right-hand rule, we're getting the same thing, but our expression doesn't work that way. So we need to come up with some way to work with that. So if we look at we're going to do that by looking at this QV section here. Okay. So QV, if we look at the units for it, it's going to be coulombs times meters per second. Well, we know that current is coulombs per second. If we regroup those, they look like this. Well, what's the meter? Well, the meter is the length of the wire that's inside of the field. So that would be the actual length that's going to be inside there. So we're going to actually replace this with an I and an L. So that means that our equation becomes F equals IL cross B. Notice that I'm writing this whole thing as a direction, IL. Technically, current is not a vector, but we're treating it that way in terms of L. Okay. Which means that, again, if it is at an angle, it's going to be ILB sine of theta. Or, if the perpendicular is good old Bill. Okay. So, and the units are going to work out the exact same way. That's how you're going to find the amount of force that's going to be in the current, or that's going to be on the current carrying wire. Okay. This isn't force from a current carrying wire. We'll talk about that later. This is just force on a current carrying wire.